Okay, welcome back. This is ELM Prep Part 9, and we're going to talk a little more about inequalities, or what you might say is another way of saying inequality is not equal to. Well, referring back a little bit to our Cartesian plot, our XY plot, let's assume I have some line, some graph. Well, every point on that line is equal to and this line has some equation where y equals some value of x plus some c maybe. So the equation, sorry about that, the equation of that line, it's saying that every point on that line is equal to this equation, whatever that equation is. I might say y equals 2/3 x plus 1. So every value of this point, if I have a y value and an x value, the equation is true. If x equaled 3, then y would have to equal 3 also. Because 3 times that would 2 plus 1, this would be 3. So this is a true statement that I have a point on this line somewhere that is 3, 3. If x were 5, that would be 10/3 plus 1, or it would be 13. If x equaled 5 over here, y would equal 13/3. This point, 5, 13/3, would be on this line. All the points on this line make this equation statement true. Well, most of the time that's what we work with. We work with the points on the line. On occasion, though, we work with the points that are not on the line. And there are an infinite number of points that are not on the line. Every point around in this area is not on the line. So all of these points are not equal to the equation. So whatever our equation is, they're not equal to it. They may be greater than, or they may be less than the equation. So whatever x, y value, it would not make my equation true. It would not equal. So in this case, y would be greater than, I'll just use the same equation, 2/3 x plus 1. So that's inclusive of all these points up here. Well, this y, whatever that is, we'll just say that this y is, we'll call this, I don't know, we'll call it 3, 3, because that was one of the points. So the y value would be greater, so we'd make the 3 greater. So the point up here might be 3, 5, 3, 7, 3, whatever. Every point above the line, the y is going to be larger than the point actually on the line. So if we're graphing the region, if we're trying to define the region where y is greater than this equation, this line, it would be all of this area above the line. Every point above the line would be greater than, so the y value would be greater than whatever x I would put in here. So if I put in some x that would normally give me this point, I'm going to get out some y that's actually above that point, an infinite number of points. So the inequalities are a region. Just like they were on our number line, they are a group of numbers or a group of values. Well, what if my equation, I should not have erased my equation, I will redo it, y 2/3 x plus 1. What if I'm looking for all the region where all the points are below the line? So all of my points are down here in this region. They're below the line, so the y is actually going to be less than what it would be if it were actually on the line. So this is going to graph all my points that are below the line. So again, the inequality is a region or group of points. Quite often it's an infinite number of points. All right, so we talked a little bit about are inequalities again, but we talked about them in terms of the x, y, or Cartesian plot. I could have let's say I have a curve like this. Well, this equation would be y equals x squared plus 2 maybe. Well, if I wanted all the points above the line, I'd define an equation y greater than x squared plus 2, and that would be all of these points up here, above the line, above the line. If I define y less than x squared plus 2, then it's all the points below the line. All the points that are on the line are equal to that equation. Y is equal to that. So this will be true. Given some x here, this y will fall right on the line if this is true. If it's greater than, then it'll be above. If it's less than, it'll be below. All right, inequalities again provide you a whole group of numbers. Okay, so let's also look at, we'll talk about that in a later one. All right, so we talked about inequalities. Again, and we talked in reference to an x-y plot rather than just a number line. But the idea again is I have when I'm using inequalities, less than, greater than, less than or equal to, greater than or equal to. These are all inequalities, and I have a group of numbers that meet that criteria. Oh, just a real quick mention of the greater than with the graph. Let's say my graph is here. If I want y greater than or equal to the equation, then it will be all the points above it, but I also have all the points that are on the line. So that will include all the points that actually are on the line. So in this situation, it's all the line plus above the line. Lots of times if it's just greater than, they will dash this line to indicate that I'm not including the line. Just a quick little, oh, I forgot my Q again. There we are, the equation. So if I'm dealing with inequalities and it's not equal to, then they dash the equation line. If it's equal to, then it will be a solid line. Just another one of those little things that we throw at you to see if you're paying attention. I know you're paying attention. All right, so that's the end of that part. Quick and short. Hope to see you again for more of our ELM prep discussion.